Step 5 is to locate the x-intercepts of the parabola and to find an appropriate equation to model the stream of water. So if we go back to the geometry sketchpad, we want an equation that will model the stream of water, which is a parabola. In order to find an equation, we will use the factored form of the quadratic equation. So if I look here, I can see that one of the factors could be x plus 1.5 because my x-intercept here is at negative 1.5. Okay, so an x-intercept at negative 1.5 will indicate that I have a factor at x plus 1.5. If I look at the y-intercept here where my hand is, this is where the parabola ends. If I create an equation for a parabola, my parabola should continue until infinity. So actually, if I were to continue with an imaginary line here, an imaginary curve, I would see that my x-intercept would be at approximately 0.4. Okay, so that would yield a factor of x minus 0.4. So let's click here in the empty space. I'll right click and say plot new function. Okay, here our graph is open downwards. So I'm going to put a negative in front. Open my bracket to write down my first factor, x plus 1.5. Okay, so I got that because my x-intercept was at minus 1.5. That means I have a factor at x plus 1.5. The next intercept is approximately, if I were to continue this line, approximately at 0.4. So I'm going to say times x minus 0.4. Okay. So if I look at this parabola here, I can change the color or make it thicker by right-clicking. I right-click and click on thick. Okay, you have to click often in empty space when you're using Geometry Sketchpad. So let's go back and click here, right-click, and I can change the color if I want to. Okay, I like the color, so I'll leave it there. Now, it kind of looks like the stream of water, but the maximum is not high enough. So if I look at the equation here, you can drag it. I didn't mean to drag all of this, so what I can do is press undo, Control Z, click in empty space. Oh, now I want to drag just my equation. Okay, so let's bring it over here to take a closer look. I'll change the color so we can see it. Okay, so we have nothing in front here. So that means basically that we have a 1 for our leading coefficient. Let's go play around with that. So I want you to do trial and error to find what would be an appropriate coefficient in front here. So we have 1. I'm going to try 1.5 just for trying it out. Press OK. Okay, so that stretched my graph a little bit higher. Now it's too high. So I'm going to go back and change this to maybe 1.2. Okay. Still, now it's a bit too low. So we're doing trial and error until we find a nice curve. Okay, now I find it should be a little bit more to the right. So we can say that the x-intercept should maybe be at 0.45. Let's try that. I'm still not happy. Let's change this maybe to 1.22. Okay, not bad. So here we have a parabola that models the stream of water. Okay, now the stream of water doesn't start here, obviously. It starts from my hand. So we can click on the graph, right-click, and say Properties. I can click on Plot. So I want to change the domain. The domain means the values that I want of x where I want to look at the graph. Okay, so the domain should be from minus 1.5. That's where it touched the ground. So minus 1.5 to where I'm holding the hose, so to my hand, which was when x was equal to 0. Okay, so these are the values, minimum value for x and the maximum value for x. I can press OK, and here we see only part of the parabola. Okay, I'm still not happy with this color here. We can't really see. Whoops, I'll press undo. I didn't want to move everything. I just wanted to move this equation. I'm going to put it in black. Okay, now we can clearly see. Make sure that we can clearly see your graph and your equation because you're going to print that later on to submit it. Okay, so this completes the second video. Once you have completed this part, please come and show me your work before you move on to video number 3.